Welcome to this OST2 lecture about the TPM 2.0 extended authorization and an introduction to TPM 2.0 policy. Before diving into the TPM 2.0 extended authorization, we need to learn what is the difference between authentication and authorization. Authentication is used to verify the user identity, based on that identity to provide a role for the user and allow access to different resources or enable different operations. Usually we do this using a password or some kind of biometric parameter. On the other hand, authorization is interested in verifying that the set of security rules are met before allowing access. This means that when we use authorization, we actually do not know the exact identity of the user. A good example is the access control list approach, where we know, for example, that a user from the developers group is trying to install a new software on the laptop, but the rules do not allow that. So we will allow the installation of new software on the company laptop only when the user is part of the admin group. But we are unaware of who that user exactly is. It's not required. It can be also a validation of the user identity, but the principle of authorization is that we focus on the set of rules that need to be met to enable what needs to happen. This can be further extended with policy-based access control systems. For example, is the laptop that we're trying to connect from running Windows? And is this operating system right now not in safe mode? Only when these two policies are met, we would allow the user from the standard group to connect to our virtual private network. And this is just an example. This is similar to how TPM 2.0 authorization works. We are authorizing commands per use. The authorization is carried by the TPM object and is defined during creation time. And only when this authorization is satisfied, we are allowed to proceed with the TPM operation. TPM objects can be authorized in two ways, using a password or using a policy. The use of policy is what we call extended authorization. To transfer the authorization information between the host and the TPM, we have authorization sessions. Out of the 5 types of TPM sessions, here we do not have listed the audit session because it has special purpose, as we already learned, and the trial session, about which we'll learn more in just a moment. By using a password session or HMAC session, we can satisfy a password authorization for the TPM. By using a policy session and only policy session, we can satisfy the TPM 2.0 extended authorization. So what is the extended authorization? The shortest definition that I like is that EA policies allows us to add additional rules on how our TPM objects can be used. And TPM 2.0 policy in essence is just a hash digest. And while it may look trivial to satisfy and match the value of a single hash digest, this is not so. We'll learn why in just a moment. We mentioned already that authorization is built in TPM objects at creation time. And this is why this is also true for the extended authorization policy, being built in the TPM object as it is being created. These additional set of rules that we can add to our TPM keys means that we can make them valid in only certain scenarios. This way, even if someone guesses or finds a way to leak the password to our TPM key, the TPM key will not work in all cases because the TPM 2.0 policy needs to be met, and the TPM 2.0 policy can be linked to the state of the system using PCR policy. Let's take a closer look at how EA policy work by using a diagram from the very informative presentation by Imran Desai during the TPM Dev 2022 conference. Imran talked about mutable policy and addressed the different misunderstandings about extended authorization. One of these misunderstandings is when can we change the policy of a TPM object? Remember, the policy is built into the object at its creation time, so changing the policy is rather an important security event, and there are restrictions on when and how this can happen, and Imran talks about this in depth, so I really recommend watching his presentation alongside the lectures in this course. Imran made a nice diagram how the TPM matches the policy digest for satisfying the extended authorization. This can be any TPM 2.0 command. And as any TPM2 object has an out value and an out policy, the digest that needs to be satisfied is carried within the command and within the object. Remember, this can be also a TPM entity like the endorsement or owner hierarchy. Out value is usually used for passwords, but of course our object can have an empty password and have just an authorization policy. As the TPM is processing the command, it will extract the digest from the out policy and try to match it with the policy digest provided in our policy session. Only upon a successful match, this command, this operation will be performed. This means that if this was a signing key, the generation of a digital signature will not be validated by just providing an out value. If the object had a password, we also need to satisfy the policy, we also need to satisfy the set of rules. And looking at it from the standpoint of having a policy digest, we are not actually aware what were the rules that were taken to generate the policy digest for this policy. So how are TPM policies created? We need to start a TPM session of trial type using EC start out session. And it is important to note the hash algorithm of our choice, because the user who wants to use our TPM objects later will need to satisfy this policy using a policy session type and also matching that hash algorithm. Otherwise, the digest will not match and thus the authorization will fail. This is a minor detail, but sometimes it can cause a headache during development. Now that we have our trial session for creating a new TPM policy, we can perform any of the TPM 2.0 commands to describe different rules to add to our key. In this case, we have EC's policy secret over the endorsement hierarchy when using the EK. And now that our trial session has been updated and the digest value is updated, we can use EC's policy get digest to retrieve the resulting value. Of course, do not forget to flush the context once you're done with the trial session and the policy is created. Here is the list of all available TPM 2.0 policy commands. As you can see, we even have a command to link the use of the object to the current level of locality by using TPM policy locality. By default, any following TPM policy command is added to the previous TPM policy rule. This means that all of our crafting of policy is a logical AND. And in case we need a logical OR, we have the TPM2 policy OR command. There is also a very useful TPM policy PCR command that we will learn in one of our following lectures, which allows us to link the use of the object to the state of the system or other property thanks to the PCRs. Here is the somewhat known policy secret from our endorsement key and endorsement hierarchy lectures. To satisfy extended authorization, we already said that we need a TPM session of policy type. The interesting bit here is that it is the TPM who actually performs the computation of the digests for the policy. When we perform TPM2 policy secret, when we perform TPM2 policy PCR, it is the TPM who computes the digest and updates it in the session. Why this is important? Well, if we're using a PCR, we wouldn't want someone externally to compute the digest over that PCR and then just provide it in the policy session command to authorize the TPM object. This is why we are required to have a TPM session of policy type. We are then required to invoke all of the TPM 2.0 policies that match the different rules of the object, and we need to invoke them in the right order. For example, we invoke TPM2 policy secret, then TPM2 policy OR, and then TPM2 policy PCR. Once we are done satisfying all of the different policy rules, we can just pass that policy session as part of our comment, and if we have indeed matched all of the rules, the TPM operation will be executed. As you can see, the complexity of TPM 2.0 policy is the reason it has so much value. So how it compares with a password? Well, the thumb of rule is that anything that can be done with a password can also be done with a policy. The opposite is not necessarily true. Here I've given an example of a very common case when duplicating a TPM key can only be authorized using a policy, but we want to use a password. What can we do? Well, we can of course use the policy password command to describe the password authorization as a policy authorization. But still, this would mean that we need a policy to satisfy the extended authorization. And here we are. Our first extended authorization will be a policy password. We are requiring the user that wants to use our TPM signing key to provide a policy rather than a password. In order to do that, we need to make sure that when we create our object, we set the user without field to a 0 and the admin with policy field to a 1. Then we also need to provide in the out policy field of our object the result of our trial session and the digest when we invoke TPM2 policy password.